Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today's special guest is Mike Nowicki, and Mike Nowicki is a solar engineer. In fact, he's a professional engineer, and he's got all kinds of special letters after his name. And I've known Mike for a while. He's been in and out of a few different classes that I teach. Seen him over here at some conferences. And more recently, Mike and I were hanging out at ACP. And if you don't know what that means that the solar people took over the wind conference. Sort of, if you're a wind person, sorry to say that. But there was this AWEA, I believe it was called, conference, and they changed it to American Clean Power. And so there's a lot of different solar people hanging out at this conference. We were in a nice air-conditioned room or group of rooms over in Arizona a few months ago, hanging out. And it's called ACP, American Clean Power. And it was kind of interesting because I'm so used to going to all these different RE Plus conferences to see another, decently sized conference with solar that had a whole different group of people. And Mike Nowicki also does a lot of utility scale and commercial stuff. And that's what that conference was about. There wasn't any residential solar things there. They were geared for the big stuff. So welcome to the show, Mike. How's it going?
It's going well, and thank you for having me. I appreciate the opportunity.
Yeah, and you're up there in, I guess you call it the Midwest, but from where I'm sitting, it looks kind of east to me. I don't know.
Yeah.
And so you're sitting in downtown Chicago, but you also do most of your stuff over there in Detroit.
Yeah, that's right. I'm from the Detroit area, just in Chicago for a few days here. This is our big regional office here in Chicago. So there's about 600 people that sit in Chicago.
Oh, great.
Maybe about 70 in Detroit. So I'm just here for a few days.
Yeah, I had some business a few years back over in Chicago and in Detroit. And I remember they upgraded my rental car to this nice Mercedes. And I thought that was a good deal until it was so smooth that I didn't notice how fast I was going, and then I got a ticket. So I actually paid to have that upgrade one way or another. But it's good for you, good for your economy, because that ticket money. So you're welcome.
Yeah.
So what have you been up to? You work for, I guess, a big engineering firm?
Yeah, I work for a large EPC company, Burns & McDonnell. We are headquartered in Kansas City. So that's the big office, the mothership, if you will. There's, several thousand people there. And Burns & McDonnell was founded in 1898. So been around for 125 plus years. We're about 13,000 people. So that's a lot of different markets and a lot of different people here. If you looked at the ENR list, which is Engineering News Record, we would be number 7 on that list as far as engineering firms.
Oh, wow.
We're number 1 in power design,
Mm-hmm.
number 1 in transmission and distribution, and number 1 in energy storage.
Wow.
And that's all basically utility scale.
Oh, great. Okay. So
Yeah.
that's pretty neat. And how did 1898, that's a long time ago, 12 years.
It's actually the youngest company I've worked for.
Oh, yeah.
Believe it or not. But the first company I worked for was Albert Kahn, and they were founded in 1895. And then from there, I worked for Smith Group, and they were founded in 1853.
Wow.
So I've worked for some very old companies in my career.
Yeah, I can't even remember those days.
Me neither.
So how does a company start off in 1898 like that now Burns McDonnell is doing, like you were saying, like building all these big, utility scale power plants and things like that. And back in 1898, I mean, things were a lot different. People were using oil lamps and stuff. So what were they doing back then?
Yeah, well, long history. I mean, there was the two founder, Burns and McDonnell, so their last names, and they started out in sort of land surveying and infrastructure, and they landed in Kansas City. That was kind of like sort of the last stop before heading out west. And around that time, sort of the Industrial Revolution and the time when like central sort of water systems and plumbing and those sorts of systems were starting to get installed for cities and things like that. So they started in, wastewater and sort of land surveying and laying out infrastructure for cities. And they decided that Kansas City was a good location. And then obviously when the grid started to get built and things like that, at the turn of the century, they jumped into power. And so we've always been in kind of utility infrastructure.
Huh. Yeah, I've been to some third world countries where the sewage is just a ditch.
Yeah.
Going down the road and, kind of.
Yeah, we kind of take that for granted here in the United States, don't we?
Uh-huh. I wonder if like back in the 1890s, might have been common. I guess, by our standards, the 1890s would have been a third world country.
Yeah.
Uh-huh.
Yeah, a lot different for sure.
So your company that you work for brought it up to first world. So thanks for doing that.
Yeah, our pleasure.
That's why I don't have cholera today,
Yeah.
Uh-huh.
Yeah, I think one of the interesting things about our company, I mean, obviously we're a real big, multi-billion-dollar engineering firm, but we're 100% employee owned.
Uh-huh. Wow. So you are part owner of your company. That's pretty neat.
Yeah, everybody is. Yeah, it's an employee stock ownership program, or ESOP.
Great.
So everybody's an owner.
Okay.
Which is pretty unique.
And is the company on the stock market?
No, it's not public. It's a private company still, but just 100% employee owned.
Oh, that's pretty neat. All right. So you're an owner. So when I said your company, it really was.
That's right. Uh-huh. Yeah, which, we kind of pride ourselves on that because as owners, we have a different mindset, I guess you could say. I mean, it's our company and we all have a vested interest to see it succeed.
Mm-hmm. Great.
So I think everybody works a little harder and, over the years here, we've definitely seen good results because of that.
Okay. So one thing that I noticed about your LinkedIn profile is it says solar engineer underneath your name. And I have a friend I actually used to teach advanced PV classes with quite a while ago now, over 15 years ago. And he's a professional engineer like yourself, professional electrical engineer. And that's what you are. And that means you passed some really hard tests and had work experience and went to school is pretty much what that means for being a professional electrical engineer, a PE. And I one time introduced him as a solar engineer, and he quickly corrected me and said that anybody could be a solar engineer, that he was a professional engineer. And he didn't want people just calling him a solar engineer because some tech support guy at some inverter company might just be calling themselves a solar engineer because there is no official solar engineer. So so that's humble.
I guess it depends on who you talk to and how serious they sort of take that title.
Yeah.
I don't worry. Me personally, I don't worry about it too much, but there are rules and requirements about registration and using those titles legally.
Mm-hmm.
So some people are a little more serious about that, and you got to watch where you apply that sort of title, I guess.
Yeah. Well, I guess like the title for PE, of course, like definitely professional engineer. Like, so every state has their own licensing. And so a PE in one state is different from a PE in another state. And I imagine, do you know how many states Burns McDonnell has PEs in?
Oh, I'd imagine all 50.
Yeah, probably all 50 plus.
Yeah. Plus the territories. Yeah. I don't know off the top of my head. I'm licensed in 4 states myself.
Great.
So.
Okay. What 4 states? All right.
Michigan, Pennsylvania, Connecticut, Nevada. And I'm in the process of getting licensed in New York.
So when you get more licenses in different states, how does that work? I guess it depends on the state. Sometimes there's reciprocity where you could just transfer it over, or do you have to take another test?
Correct. No, there's, just like you said, reciprocity. So the organization that administers the exam and kind of keeps track of those records is the NCEES. And I know you're big on defining acronyms because I listened to your podcast before, but off the top of my head, I don't want to get that acronym wrong, but it's the National Council of, I can't remember what it is.
I got it right here. I just looked it up. National Council of Examiners for Engineering and Surveying.
Perfect. Yep. That's it. So they're the entity in charge of the exams and approving, passing exams and things like that. And through them, you can, earn or establish your NCEES record. And that's a process you go through where you verify your passing exams, the FE, Fundamentals of Engineering, and the PE, Professional Engineering exam. And they verify your work history, and you need references from PEs in the industry, and they do background checks. And once you establish your NCEES record, then it's much easier to apply for reciprocity to other states. You basically submit your record to the boards, the state boards, and it sort of streamlines the process. And at that point, you just pay your fees for your license, and there's a review period. And if all goes well, you get licensed in that state. And then there's an ongoing recertification and fees every year. And sometimes there's continuing education requirements. You have to have so many credits, but it varies by state.
So do you ever have to take the exam for different states?
I haven't yet, and I hope I never have to again.
Uh-huh. And this happens for all different kinds of things, for doctors, for lawyers, for, electricians. Every state has different rules. And so, for instance, for electricians, sometimes there's reciprocity and a lot of times there's not. And then you have to go take another test. And you can't work in a different state, even if that state is just across a river or across the street. A lot of times, you can't work there. Like, so I have an electrical contractor's license in California. And if I was living across the street from Nevada, I couldn't go and do work there without, going through the Nevada board and all that kind of stuff and paying money and having them look at me with a microscope.
That's correct. And different states are, more strict and have more stringent requirements and things like that. So you really got to do your homework and look those things up.
One time I had a guy in my class that worked for SunPower, and he was pretty much their qualifier for, electrical contracting. And so they would do everything under his license in all the different states. And he had a pretty cool life, because once you pass one state's exam, the other one might not be that difficult because they're very closely related to each other. So he just went and he applied for all these different contractors' licenses, and he would sometimes ride his motorcycle across the country taking different contractors' license exams, and it made him valuable. And he was in my class so he could get his NABCEP certification too. And one thing that was kind of funny was when he was in the class, he was trying to apply for the NABCEP exam, and he was saying, which jobs should I use to qualify for this NABCEP exam? Because, you need to have some work experience for the PV installation professional exam. And he had, one of his options was his license was used for the world's largest solar project at the time. And I was like, yeah, use that one. And he's like, no, that's like too much paperwork. I'm just going to do a residential one. But I thought that would have been kind of cool for, using the world's largest one, which at the time, it was probably like 10 years ago or something. And it was something like a 500 megawatt solar system in California that SunPower did. But that was kind of neat. But yeah, people should look out for all these different, licensing requirements and things like that. And also, it's another good thing to have, so you're valuable. And some people are satisfied with, just like getting their entry-level solar job and sticking with that the whole time and being on, working on a roof, bolting rails to a roof or something like that. But there's other people too that will keep getting educated, keep learning, getting certifications and licenses and things like that. And then they will keep moving up. And people that have the good license will make a lot more money. Like you first have your level one money that's just like, minimum wage even, or something closer to that. And then if you keep moving up, you could be making like 10 or 100 times more. And so that gives you a lot more options in life. But you have to work hard, but then you're just using your brain and you're less likely to get too much sunburn, which could be unhealthy.
Yeah, I mean, education and investing in yourself is always a good thing. In the engineering world, if you want to take that step to project leader or into management or something like that, having your credentials like a PE or registered architect or something, that's sort of a requirement. I mean, if you want to be taken seriously in your firm, you have to have those minimal credentials. You have to be able to seal and stamp projects, and the PE certification, it opens doors for you. I mean, at that point, you can start your own firm as well.
Yeah.
You can work, for the municipalities and other clients, and, you're not going to be able to do certain projects without a PE. So,
yeah. And a lot of times just what people call it is that you have a stamp in different jurisdictions. And sometimes in the National Electrical Code too, like say Article 690, 690.7 and 690.8. And so 690 is for solar photovoltaic systems, 690.7 is for voltage, 690.8 is for current, and defining all these terms and figuring out how to size wires and things like that and determine your voltage. And so there's certain requirements, or you could say different ways of calculating voltage and current, where if the system is 100 kilowatts or larger, and that would be like they say generating capacity, so that's the output of the inverter. So if it's 100 kilowatts or larger, you can have more leeway under engineering supervision with a professional electrical engineer so that you can use a smaller wire that you would otherwise have to use. That would be for current. And you could also put more PV modules in series. I imagine you're probably doing that kind of stuff all the time.
Yeah, that is correct. For our systems, we typically use a program called System Advisory Model, like SAM, which was developed by the NREL.
Great.
I don't know if you're familiar with that.
Sure. NREL, National Renewable Energy Lab. I was just over at the American Solar Energy Society conference. And while I was teaching a class all day for 7 hours, other people were touring NREL.
Yeah, I've been there as well and toured their facility.
Yeah, so if anybody's ever up there in the Denver area, you can schedule a tour, and it's like, I don't know, something like $1 billion lab with some of the smartest people in the world. And they have like solar, and they have all different types of things there. And it's pretty neat. I first went there when I was working with what sometimes is called the PV Industry Forum, Solar and Storage Industry Forum. They kind of changed the names. And you can sign up to be on those committees through SEIA, Solar Energy Industry Association. And you can, help write the National Electrical Code, come up with different ideas. And so we used to meet more in person before everything went online, because some kind of thing happened in 2019, 2020 that we all know about. And it made it so everybody just got really comfortable doing stuff online. So maybe, there's always a good thing when bad things happen. But anyway, we used to go meet in person more. And we would meet at NREL, and we'd have these big tables with all these super smart people figuring out what to put in the National Electrical Code. So it's pretty neat. Yep.
Yeah.
We still do meet in person sometimes. So I know at the RE Plus conference that's in Las Vegas, we meet at that conference and in person and kind of go over things. So it's kind of neat. Yep.
Yeah, I've attended your class at RE Plus in the past. You and Bill Brooks.
Yeah, with me and Bill. And so Bill, I kind of look as sort of the ringleader. He's usually the smartest person in the room, and he's, figuring out what's going to be in the code and telling people if their idea is good or bad and stuff like that. And people pretty much a lot of times go along with what Bill says. And he's also not paid to go to these meetings. So it kind of gives him an extra layer of authenticity, because a lot of people are going to these meetings because they're paid by their employer, and he just kind of shows up and he just really understands all of these things. And so Bill and I write a book together too called PV in the NEC, and usually I get my first look. Oh, there you got it.
Yeah, I got it.
All right. And usually I get my first look at the NEC from Bill. And sometimes it's even like a Word document. He's like, it's not 100% right, but this is pretty much it. And then we start, pretty soon it's going to be book writing time, because we're going to get a copy of the 2026 NEC. And for me, actually, it always seems like it's book writing time. And then we try to make it fun, because, the NEC sometimes isn't as fun as it could be. So anyway, you took our RE Plus class, and we've been doing that one. Let's see, I think
for a while.
Yeah, I think we hit our 10th, or 10 years in a row, except that we did have a little bit time off because of those interesting things happening in 2020 when things went online. But 2014, I did it used to be called Solar Power International before they.
Yeah, SPI. I used to attend when it was SPI. Yeah, the first time I met Bill was in 2011.
Oh, great.
He taught PV boot camp, PV solar boot camp. It was Bill and Mike Holt and Greg Smith and Jim Dunlop and Dave Click and some other folks. Like Ryan Mayfield was one of the instructors.
Okay. Yeah, I did that one time. I'm trying to remember what year that was, but I think it might have been.
I think you were at that.
Yeah, I think I did it. It was in Florida. It was like it's probably like 2014 or something like that.
Yeah.
Or 2011. I can't remember if it was at 2011 or 2014 NEC. But yeah, that was fun. Yeah.
Yeah, my favorite publication was Solar Pro. I used to read that from front to back, man.
Yeah, me too. That's where I learned a lot of stuff, was from Solar Pro or Solar Professional magazine. I always had like a Solar Pro sticker on my computer. And then it had a 10-year run, 2008 to 2018. And then you can still download and learn from every different issue. However, it used to be when I was doing an internet search that it would just pop up all over the place. Like I'd be learning like combiner box wiring or something, and a Solar Pro article would pop up. And now it doesn't do that anymore, because all you can do is download every issue for free. So what I did on my website is I just made an index. So every Solar Pro article is indexed at SolarSEAN.com. So
yeah, I saw that. Yeah, that's good. Thank you for doing that.
Oh, thanks. Yeah.
I think just I'll mention here, because we're all about education here. I think Ryan Mayfield does a great job too of educating the industry and posting his content, and he's got a variety of things, articles and videos and everything on his website. So if people haven't checked that out, I think Ryan is a great resource too.
Yeah, great. I was on the Mike Holt panel with Ryan. I guess it was the 2014 NEC. And so I definitely know Ryan very well. He's up there in Oregon, and I see him all over the place too. So great. And I know that Ryan works on not with the Code Making Panel 4 for solar with Bill, but on Code Making Panel 13 for energy storage. So there's like different code making panels, CMPs, and it's a lot of work. I would get more involved in that, but it's like I have so many things to do. Just a lot of work. Unless somebody wants to sponsor me, that would be a good idea. So I kind of figure like what I do is like they make all these rules on these code making panels for the NEC, and then I write the book and find their mistakes and make fun of them. That's my job. It's a lot easier, more rewarding. Yeah.
Well, I would be interested in working on some of those code making panels. So if there's ever an opportunity, feel free to pass it my way.
Oh, for sure. Yeah. It's called the Solar and Storage Industry Forum right now, SSIF. And remind me, and I could send you an email of one of the people, just like copy you, and they'll put you on the list. And I'm pretty sure that SIA has a page where you can just go and you can sign up, and we'll put that in the show notes. The page, there's like Evelyn and Caesar, and those are two of the people that can, I'm pretty sure, get you on the list. So
that'd be great. I think it's important too to have some independent folks representing those panels as well, and not get too heavy with manufacturers and things like that could potentially look out for their own interests rather than just for the betterment of the industry, if that makes sense.
Yeah, I can remember like when Rapid Shutdown came out, everybody was blaming it like on Enphase and Solar Edge, and they're like those people. And I remember that Fronius hired me to do some consulting, and they're like, okay, what do we do here? And it's like, well, you should have been at that meeting. And I think when they were deciding what to do. And so it was, I'm trying to think if it was a 2011 or the 2014 NEC. So it was probably it was in 2011 when they came up with the rules for the 2014 NEC, but that wasn't really module level. So I think it was 2014. We had a meeting at NREL actually, and it was for the 2017 NEC. And that's where they got more where it was module level. Rapid shutdown was the way of doing it, and that's for PV systems on buildings. But then they had different methods of doing it. And so it was a listed label rapid shutdown system, which now means UL 3741, which everybody's talking about.
Right.
But they didn't have any standard.
They didn't have any product out there at the time either. So it came out in the 2017 code, but module level rapid shutdown didn't go into effect till January 1st, 2019, I believe. I don't know if you remember that.
Yeah.
They had sort of a gap there, a grace period, so that manufacturers could come out with product to satisfy that requirement.
Yeah, so that was right. So, and then California didn't adopt the 2017 NEC till 3 years later, which they always do. So for California, it would have been 2020, where you had to do module level. And back then, half the whole solar industry was in California in the United States.
Yeah.
And so it was all of a sudden 2020 came along and everybody's like, what are we going to do here? And everybody was like, well, I think in December 2020, I believe, is when they even came up with UL 3741, or, they actually had the real standard. And then it takes years before people start testing to the standard and all that kind of stuff. So for rapid shutdown, pretty much what everybody was doing for either 2019 or 2020, depending on when things were adopted, we're just using module level power electronics. So that's mostly was Enphase and SolarEdge. It was really good for their stock at that time. But now there's a lot of these systems that are listed to UL 3741, and many of them are systems where you can have full array voltage after shutdown, which according to Bill Brooks is, not really what was intended, especially when you have metal framed modules. But
right.
There's always drama. Yep.
Yeah, I remember him talking about it, and I think it was last year or the year before. That was not his intent, or the code making panel's intent, I should say. Mm-hmm. But yeah, I don't really care for the rapid shutdown electronics. I've had projects where we've had issues. I think looking at the system, it adds cost and it adds a lot more failure points.
Mm-hmm. Yeah.
So is the system safer? I don't know. Is it more reliable? I don't know. So I have mixed feelings.
Yeah, sure. When you put a whole bunch of electronics up there, there's going to be some of them are going to break just by the numbers. If one breaks every 30 years and you have 30 of them, that's going to be average of one a year. If you have 60, average of two a year.
And they got to be compatible with the inverter, and they got to be able to communicate properly, or you have crosstalk issues. And, when that first came out in the code, that was one of the issues that I don't think the industry really knew about in the beginning. So there were some major failures that were happening.
Yeah. For everything, there's benefits and drawbacks. And so, so the drawbacks, we've just kind of covered some of those, or some people even say, there's been fires that were caused by rapid shutdown devices. But the reason they put it in there is for firefighter safety. So firefighters will not say what they used to always say, where the PV system was on a building, and that was the 3 words, let it burn. So now we have firefighters that are more likely to go up there and save a building, which brings down insurance costs and things like that too. So,
right.
Yeah, benefits and drawbacks to everything. And there's I guess we could probably do 1 or 10 podcasts on the benefits and drawbacks of rapid shutdown. And one of the things that I get a kick out of is I try to remain neutral. I figure that's my job as an educator, is to tell you the pluses and minuses of both sides on an issue. But I kind of get a kick out of people getting really passionate and mad at each other. And they're like, I don't like this person because they have a different idea about rapid shutdown and they're an awful person. Yeah. And it's just we can all have our own opinions, even politically. I think it's healthy to have friends that are on both sides,
Right. Yeah. Well, that's kind of how it used to be, but I think, society has become a little more polarized. I just try to stay out of
Yeah, I know.
that.
It's kind of funny how like politics takes sides with even things like rapid shutdown. So I wonder who's going to be like pro and who's going to be against rapid shutdown. Is it the Democrats or Republicans? And then where does the Green Party stand on rapid shutdown?
Yeah, right. Yeah.
And so like that's another thing too, is like I guess too with things like rapid shutdown, you could have like Democrats and Republicans on both sides of the issue. So there's always some place where we can agree. It's kind of funny how to relate all those things. We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. So you do like big projects. What's the biggest project you've worked on?
Yeah, so I've been with McDonnell for about a year, a little over a year. Before that, I was doing commercial scale systems. So in the year that I've been here, the biggest I've worked on is 200 megawatts DC.
200 megawatts DC. And then there's always a PV to inverter ratio. So what kind of ratios are you working with?
I would say probably 1.3 to 1.4 is generally DC to AC.
Yeah, so that would mean that you'd have like 30 or 40% more PV, which is rated at standard test conditions, which are overly optimistic, to 1.4 to 1 ratio. And so the 1 is the inverter output. So that would be the AC output of the inverter. And some people kind of, when they're first learning about PV, or some homeowner might freak out and go like, somebody's ripping me off, but they're just rated differently. One of them is the output after all these derating factors. And then standard test conditions is like, good sunlight and cool solar cells. It's like you have to be like aiming right at the PV. In worst case scenario, and it's not worse, but like sometimes you clip a little bit. And if you're just clipping a little bit, not a big deal. Do you come up with like what percentage of your power is clipped in these systems?
Yeah, we do. We run a PV-SYST model.
Mm-hmm.
So PV-SYST is a sophisticated, I'll say, modeling software where we can look at the whole system, can do financial analysis. It looks at the performance of the system, and it has a lot of inputs and variables. So we model that system, and it gives you sort of a system losses diagram. So you can see exactly, at least, a modeled system, you can see what those losses are going to be.
Mm-hmm. Great.
And it's part of the cost benefit analysis, right?
Mm-hmm.
If you buy larger inverters and reduce your DC to AC ratio, you're kind of paying more money. And so if you increase that DC to AC ratio a bit and buy a smaller inverter, there's the payback associated with that. There's going to be some power loss, but you save some money. So you can kind of look at that and find the sweet spot of what's sort of the acceptable range.
Yeah, and then also when you're clipping, there's an abundance of solar energy, so perhaps the solar energy isn't as valuable at those times anyway, like it would be more in the afternoon when people use more electricity and the sun starts setting. So when you're doing your PV-SYST, which is like the software that's the go-to for utility scale solar systems, that's made in Geneva, and I think Bill Brooks had something to do with making it popular back in the day. So when you're using that software, do you have like a range of percentage of what's acceptable for clipping, just kind of like off the cuff in general?
That's a good question. I guess it just depends on the system and the specific application.
Yeah, like I used to do solar training in Ontario, Canada, when they had a feed-in tariff, and that feed-in tariff limited you to 10 kilowatt PV system, and they could DC or AC. It didn't really say. And so if the PV is inexpensive and you can get that kind of money, I would say that you could probably do a 2-to-1 ratio, And then you would just be clipping in the middle of the day when it's sunny, not on a cloudy day or anything like that. And then you'd be making a lot more in the morning, a lot more in the afternoon.
Right.
And I've actually heard of people doing that. And it would be a little bit different, like your PV to an inverter ratio. That metric doesn't make as much sense if you're doing like DC coupling. So if you're sharing an inverter with some batteries and you could charge the batteries with the PV on the DC side, they call that DC coupling, or DC interconnected is the 2023 NEC term for that. DC interconnected instead of DC coupling. But when you're doing that, then you could capture all those losses in your battery a lot of the times. So you're just sharing an inverter and you send that power out. Are you mostly doing AC coupled systems or AC systems?
We have an energy storage group here. It's kind of a separate group. So I haven't personally worked on the storage side. Most of our projects are just solar. We're starting to see more solar plus storage.
And are most of the projects you're working on like in the Midwest where you are, or do you work on them all over the country?
We've worked all over the country, but I would say we found our sweet spot in the Midwest. California, Texas, they're very competitive. And I think they're, leading the country and sort of ahead of the pack, right? They're well-established markets. The Midwest is probably doing a little bit of catch up here.
Yeah.
So I think they're earlier in their sort of evolution of, PV and solar transition. So, so we've kind of stayed in the Midwest, Michigan, Illinois, Wisconsin, Indiana, a little bit of Iowa. That's kind of our sweet spot.
Yeah, great.
Burns & McDonnell, we have a couple companies. So there's Burns & McDonnell Engineering. There's also ASCO, which is our construction company. ASCO meaning A to Z, construction from A to Z. That's where the name comes from. And then we have a business consulting company called 1898 Company. So we kind of cover the whole spectrum, I guess. We have that early sort of feasibility study, business consulting concept with 1898, and then the engineering, Burns & McDonnell, engineering, and then ASCO, which construct the projects. So that's one thing that makes us unique is we have our engineering in-house. A lot of the EPC companies, they're construction companies, and they have partnerships or outside engineering firms that they work with and partner with.
So they say that about 2/3 of the solar that's installed in the United States is utility scale. So it's not rooftop or anything like that. And most utility scale these days is done with bifacial modules and on single axis trackers. And is that what you see from where you sit?
Yeah, I would agree with that. Projects we've done or I've been involved in, it's definitely the case.
How many kilowatts would you say like one motor might control?
That's a good question. I guess it depends on the tracker manufacturer, but one motor can control several tracker rows, and a tracker row can have 1, 2, 3, or 4 strings. And a string is generally, depends on the module, but 25 to 27 modules per string.
Yeah.
So I haven't done the math, but it's quite a few. I would, a block in an inverter block, you're 4 to 5 megawatts or MVA, megavolt amps, and you may have, anywhere from 3 to 5 tracker motors. So
Okay.
let's say it's 4 tracker motors, it'd be like a megawatt per motor.
Great. Okay. That's a good, powerful motor.
Yeah, they move, pretty slow, and it's not like an industrial motor that's moving at 1800 RPMs or something like that.
So Mike, what are some other things that you've been up to?
I'm an adjunct professor at a local university here in Detroit. It's called Lawrence Technological University. And so I've been teaching there since 2013, I think. So I'm coming up on 13 years here.
Wow.
And I teach electrical courses on power distribution and then power systems analysis, which would mean like how to calculate and do studies for short circuit, overcurrent protective device coordination, arc flash, and power quality and things like that, using software like SKM.
So this is some really big, parts of the grid, I guess, that you're talking about. So are you working like medium voltage and even high voltage in these classes?
Well, generally it was commercial where I'm teaching the students, but now as I've joined Burns McDonnell and I've scaled up, right, to utility scale systems, I'm starting to incorporate some of those higher voltages and some of those studies into my courses. Because for the utility scale, there's definitely a lot of engineering studies that have to be done to see what the impact of that PV plant is going to be on the grid, and things like load flow and reactive power, harmonics, definitely short circuit. There's grounding studies, there's transient overvoltage studies. There's probably, 6 to 8 key studies that we have to do to see, how the interconnection will impact the grid. Starting to incorporate that content into my courses.
Great. That's some real important stuff. So give us a lesson. What's a more recent lesson that, like, just for instance, like your most recent class, what were you talking about?
Yeah. So the spring course, it's the power systems analysis. So short circuit and coordination and arc flash primarily. So we go through what a short circuit is, and then the sort of the physics of what happens in a short circuit, and then how to do the calculations and make sure that breakers and fuses or overcurrent protective devices, they have the proper interrupt ratings so that they can safely open and clear a fault. We use short circuit and fault interchangeably. It's the same thing. And then we coordinate the breakers to make sure that coordination is the definition is the localization of an outage. So when a fault happens, we want the breaker closest to the fault or the fuse closest to the fault to open and operate and clear that fault. For example, if we had a branch circuit, like a 20 amp circuit, right? And there's a short circuit on that circuit, we don't want that issue to trip the main breaker in like a commercial building. For example, like a hospital. You can't have a low level fault, take out your main breaker and, take out power to an entire facility. So coordination is the process of looking at those devices, and they have an associated time current curve. We look at these curves on a graph and we make sure they align properly so that, again, the device closest to the fault operates first to clear the issue. So that's kind of a lesson on coordination.
Okay, that's pretty neat. And then I'm sure that relates to things like when we're talking about like feeders and feeder taps, and when we're talking about supply side connections and all these like ampere interrupt rating. And it is kind of interesting that a lot of people think about like a circuit breaker, like your 20 amp circuit breaker or whatever. It has this rating for 20 amps, but it also has this other rating for thousands of amps. And there's like, you get to a point where there's too many amps that it can handle, that it can't even handle it. Like it might catch fire or something,
Yeah. So that 20 amp rating is the continuous current, normal operating current of the device. And so your breaker and your wire is going to be sized for that rating. But then there's also a short circuit current rating. And that's, a branch device is probably 10,000 amps typically. And the wire has a short circuit current rating on it as well. So basically, how long can that wire sustain a high fault current, right? So we have to calculate that. And so when there's a short circuit in a system or a fault in a system, what we're going to see is a huge influx of current flow. And that's basically the primary source of that is the utility company. So the utility is this giant source. And if there's a short circuit happening in your facility or your house, the utility doesn't just shut off. It's gonna, your fault is a small blip. So the power just continues to flow to your system.
Well, except for Chuck Norris. When there's a problem on a line with Chuck Norris, he's the source of the fault. He's the source of all currents. And everybody else, that it comes from the utility. So
Yeah.
I don't know if some people might not have heard of Chuck Norris jokes, but when Chuck Norris jumps, he doesn't go up, the earth goes down. So,
The other source of fault current would be any kind of spinning machine or motor in a building. So once those motors are spinning and they have inertia, and at the instance a fault happens, now they become little generators, and they start to discharge the energy that's stored in those motors and that inertia and the magnetic fields of those rotating machines. So that's basically sent back into the system. So the combination of all the spinning machines and the utility provides that fault current source. And all the components in the system have to be rated to withstand that current. And that high current flow produces heat. It produces mechanical stresses on the system, because when the current flows, it produces a magnetic field, and those fields produce a force on all the components, and the bus bars and the wires and everything in the system. So you have a short circuit current rating that withstands all those mechanical forces. And then you have an interrupt rating on the devices that, can clearly open the device and clear the fault. So we have to go through as engineers, and this is maybe one of the most important thing that we do. We have to make sure everything's properly rated in case there's a fault in the system. And so we got to size wire, we got to size breakers, and we have to have all the proper ratings to make sure the system's fully protected, to protect the equipment and protect human life.
Great. Well, this all sounds like really good stuff to talk about in another podcast. We should do another one sometime where we get deep into these topics, if you want to do that. Okay, great.
Yeah, sure.
So let's see. So is there anything else that we want to cover today?
Yeah, no, I think that's good.
Okay, great.
I don't have anything exactly.
No, that's great. So just want to thank everyone for listening to Sean White's Solar and Energy Storage podcast. And thank you so much, Mike Nowicki, and your professional engineering knowledge and your solar engineering knowledge. And I hope to get back to you another time, and we could go deep and learn about all of these different things about fault currents and spinning motors and how all of that works too, since you're teaching that. And I like to be as educational as possible. And to get yourself NABCEP certified or learn about my classes, such as my class that I'm teaching with Bill Brooks over at the RE Plus conferences and the Intersolar conferences and all that, you can go check it out on my website, Solar, SEAN, that's SolarSEAN.com, and have a good one. Woo!